All right, today we're going to talk about our last type of transformation. To this point, we've covered translations, reflections, and rotations, all three of which were rigid motions, which means that when we transformed using those particular types, we didn't change the size or shape of the object. So when we translated, it stayed the same size. When we rotated, it stayed the same size, and so on. The new type of transformation that we're going to talk about, dilations, is not a rigid motion because we're going to be changing the size of the object. So the first thing we need to discuss is what a dilation is. So a dilation is a transformation that makes a figure larger or smaller. So we're actually going to take an object and make it bigger, or we're going to shrink it down. Now the way we do that is by using what we call a scale factor. And so for scale factors, we're going to denote those with that lowercase k. And so that's something you're going to need to know for different problems or instructions within the assignments and quizzes. So that lowercase k is talking about the scale factor. That's telling us about how much larger or smaller the object becomes. So the thing to take away from here, which is really important, is how to calculate the scale factor, or given a scale factor, know exactly what that means for the problem. So the scale factor, k, is going to be any image length divided by any pre-image length that's corresponding to it. So one of the first things that's going to be important is knowing which figure is the image, which figure is the pre-image. So which one did we start with, which one did we go to? And again, a lot of times in the problem, the prime notation can kind of help us out with that. So for instance, right here I see P prime, which means this green triangle would be the image of this transformation, whereas just regular P right here tells me that this black triangle is the pre-image. Okay, so I need to know which is which. Now, as far as calculating, we know that we just said we take any pre-image and put it on the bottom. We take any image length and put it on the top. Now, that can come in many different forms. So maybe they tell me that this length from P prime to Q prime is 5. Well, I'm going to change that. Maybe they tell us that P prime to Q prime is 10. And then they tell us that the length from P to Q, so this would be the corresponding side length. P prime, Q prime matches up with PQ. Let's say they tell us that that's 5. Well, so if I want to calculate the scale factor for that, I'm going to take the image value, so my image was P prime, Q prime, 10, and put it over my pre-image value of 5. And so I take 10 divided by 5, my scale factor would be 2. They can give us all kinds of different information involving lengths. So they could also give us something in the problem like the distance from C to P is 4 units, and the distance from C all the way out to P prime is 16 units. So I've got this distance from C to P, I've got the distance from C to P prime. So again, I can take the image length. It doesn't matter if it's part of the figure or not. It's just anything that has to do with the image. So in this case, 16 divided by my pre-image, which is 4, and I get a scale factor of 4. So when you're looking at calculating scale factor, pick any 2 corresponding lengths. So any 2 corresponding lengths, and make sure you put image on top, pre-image on bottom. Okay? Now when we do dilate, making things bigger or smaller have specific terms that are associated. And then the scale factor itself will also tell us what type of transformation we're dealing with. So if the scale factor for a given dilation is greater than 1, so if we get a fraction that's bigger than 1, like 5 over 4, or 2 or 3, like if it's a whole number. So any scale factor that's greater than 1 means that our figure is going to get bigger, and we call that an enlargement. So the figure is going to get bigger than what it was before. So if we look at our figures on the right here, I have triangle ABC on the left with triangle A prime, B prime, C prime on the right here. Well, so ABC is my pre-image, A prime, B prime, C prime is my image. I notice that my image is bigger. So this enlargement is what's happening in this particular instance. Now, as far as scale factor, because with every dilation, scale factor is going to be a key piece, what I need are specific lengths, and I can get those lengths from anywhere. So for instance, I can count any distance that I can find easily on a coordinate plane. So from A to B, I have a total length of 2. From A prime, B prime, I have a total length of 4. And so as far as scale factor, I take image 4 over pre-image 2, and so this enlargement has a scale factor of 2, which is bigger than 1, which is what I expect. So when you get a scale factor that's bigger than 1, you're going to make your object bigger. The other type that we get is called a reduction. So if our scale factor is less than 1, then the figure is going to get smaller. We call that a reduction. So if I look at my second object here, or second item, I've got triangle ABC, and then I've got triangle A prime, B prime, C prime right here. And so what happened was from ABC, my pre-image, to A prime, B prime, C prime, my image, I got smaller. So I have a reduction that's happening. So if I want to figure out, well, what's my scale factor for something like this? Again, we just have to simply count. So we find an easy length to count for. So again, if I use AB, AB has a length of 2, and then A prime, B prime has a length of 1. So then if I want my scale factor, image 1 over pre-image 2, I get a scale factor of 1/2. 1/2 is less than 1, so it reduced like we expected. So when you're given figures on a coordinate plane, like we see in this next example, all we have to do is simply find distances that are easy to calculate and count them out. And that can be with anything. We can count with diagonals, we can look at coordinates, anything that gives us a relationship between the original figure and the new. So they're telling us in the figure here, J prime, K prime, L prime, M prime is the dilation image. So they're telling us that this red object here that I'm going to highlight in green, that's the image, that's the result. The center of dilation is at 0, or O, I mean. So at the origin, so it says it's the dilation and enlargement or a reduction. Now that part should be pretty straightforward. Look to see, did it get bigger or did it get smaller? Well, so my object that I highlighted is smaller than the original, so that's a reduction. So that's the first part of the answer. Now the second part says, what's the scale factor? So what is K? Well, so in that case, like I said, all I have to do is find any coordinates that match up, any lengths that match up, anything that I can use to go ahead and plug in a length for image and a length for pre-image. So for instance, I could look at like from M prime to L prime. So if I notice that just comes across 1, 2, 3 units across, and with diagonals, that's not the true distance from M prime to L prime, but it's covering a span of 3 units along X. So that's my image, 3. When I match it with its corresponding pre-image, ML, I can see, well, how far did it span from left to right? So we go 1, 2, 3, 4, 5, 6. So there's my pre-image. And so then if I take 3 over 6, that can reduce down to 1 over 2. So basically what we're saying is J prime, K prime, L prime, M prime was half as big as JKLM. Now that was one option that I could choose for the scale factor. Another thing I could do if I wanted to was just take a look at like where the points are located. So notice that K prime is at 2 on X, where K is all the way out at 4. Well, so if that's the case, I can calculate my scale factor using those coordinates. I was at 2 for X for my image, 4 for my pre-image. I still get a scale factor of 1/2. So it can be as easy as looking at the points, or it can be as simple as counting distances within the graph. But just make sure you always put image over pre-image. When we want to calculate dilation points, it's a matter of just multiplying. So if I get a set of points and they say, here's the scale factor, I simply take the scale factor and multiply my original points. So here's what this rule looks like right here. It's just saying take your original X and Y, take whatever the scale factor was and multiply. So take K times Y, or K times X and K times Y. So in the example below, A was at -1,4, and it says, where would A prime be? So where would A prime be after a dilation with a scale factor of 20? So if I have a scale factor of 20, what I'm going to be doing here is I'm going to be taking -1 times 20. So -1 times 20 is -20. So there's my x-coordinate for A prime. And then I do the same thing for y. So if I want to go y, I'm going to take 4 times 20. And so y would end up at 80. And so I end up with A prime at -20, +80. So it's just a matter of multiplying each value by the scale factor. So we can then use that to actually perform dilations. So in a situation like this, they're going to start you with a pre-image. So they're going to start you with some coordinates. So A is at -2, +3. B is at 3, 1. And C is at 0, -3. So what we start with is this figure here. Now what they're telling us then is that we have a scale factor. So we're going to apply a scale factor. We're going to dilate this, and we're going to use a scale factor of 2. So what that means is I need to take all of my original coordinates and multiply them by 2. So that's where A prime down here, -2 times 2 is -4, 3 times 2 is 6. So A prime goes out to -4, +6. B prime, multiply the 3 and the 1 by 2 and we get 6 and 2. So B prime is at +6, +2. And then finally C prime, 0, -3, multiply everything by 2, we get 0, -6. And so then C prime comes out like that. And so now when I connect my new dots, I end up with my new figure. So then the image, my dilation, would be that A prime, B prime, C prime. And again, with these types of problems, you can either plot the new points, or in this case, it's a lot easier to find the image points first. So multiply everything out and then replot them. But you need to have both parts. You need to have the image points, and you need to have the actual figure graphed as well. So that would be an enlargement example. Same thing with the next one. If we have the points 0, 0 for A, 3, 0 for B, and 3, 2 for C. Here's my original picture, my pre-image. It says apply a scale factor of 3. So again, we're going to calculate our new image points. And so that's what we have right down here. So 0, 0 times 3 is 0, 0. 3, 0 times 3 is 9, 0. And 3, 2 times 3 is 9, 6. So if we plot those new points, A prime actually ends up in the exact same location as A. B prime ends up at 9, 0. And C prime ends up at 9, 6. And so then I have the exact same shape, but larger. So A prime, B prime, and C prime, we've got our graph, and we've got our coordinates. That's what we need for our answer. If we look at some reductions here, same thing applies. We start with our original pre-image points. So A is at -10, 10. B is at -6, +8. And C is at -8, +4. And again, make sure you're always labeling your points so we get this shape to begin. From there, our scale factor is a +1/2, so we just take that scale factor and multiply everything by 1/2. So for my new image points, multiplying by 1/2 is like dividing everything by 2. So -10, 10 becomes -5, 5. So A prime moves to -5, 5. B prime, when we take -6, 8 and divide everything by 2, we get -3, +4. So we get B prime. And then C prime is -4, +2 once we divide our original points. And so now we get this smaller, reduced picture, A prime, B prime, C prime. Okay. Same thing with the next one. So given a particular shape, we have first start by graphing. So -3, 3 is A. -3, -6 is B. And -9, 0 is C. So we have this shape to begin with. And now if we apply our scale factor of 1/3, again, when we multiply by 1/3, that's the same as dividing by 3. So negative 3, 3 becomes negative 1, 1, and there's A prime. B was negative 3, negative 6. Divide everything by 3, we get negative 1, negative 2, so there's B prime. And then C prime moves to negative 3, 0, and so then we get this dilated image here. So when you're working on the dilations, just multiply all the terms by your scale factor. Plot them, you get your new image. With that, you should be able to work on the worksheet from class. So you need to get that worksheet either off Google Classroom or from class. As you work through it, if you have questions, make sure you ask, email, check the answer key when it comes out. But everything should be following along pretty closely to what we talked about in the notes here. So if you have any questions, let us know. And then, like I said, make sure that's ready to go in a couple days to turn in.